another NAND gate. So here these two NAND gate combinedly work as a 3-input NAND gate. Here you can see that output of Q bar is given to this NAND gate, and the output of Q is given to this NAND gate. So this combination of these two NAND gate is giving you the facility of 3-input NAND gate. Now initially here you can see that all the outputs are unknown. Okay. Now here in the JK, master slave JK, the slave is the clock pulse for slave is inverse of that in master clock pulse. So here I have used a NOT gate here. So initially the circuit is means all the outputs are unknown. Now if I select that do case analysis, means what, the selection will be here, then you click on that do case analysis, then selection will come here. Okay, now you select the clock, then you start the simulate, then you do gate by gate simulate, and then you start the clock. So yet the clock is changing, but still the values means q bar, all values are unknown, means x. Okay, so now again you click on this particular simulator, means which one, this gate by gate simulation, then the values are changed. Here you see that q is become 0 and q1 become a q bar is become 1, and here you see that there is race around condition arise. That's why there is a particular error is showing that the race around condition is there in the circuit. So every time the particular circuit is facing the race around condition, now race around condition is appear, that means what, that particular here you can see that there is no such case should be arise where both q and q bar should be 1 1, because what, that q is 0 then q bar will be 1, if q is 1 then q bar will be 0. So but here it is 1 1 because of this particular race around condition. So that is not a problem. Your goal is design the circuit with this in case of D flip flop, master step D flip flop, you need this 10 NAND gate. Okay, and this NOT gate clock and the input, but here in D flip flop you don't have to give the JK separately, you give D and then use a NOT gate, and inverse of D should be inputted in the this another NAND gate. Okay, so you have to design that circuit. Now if I use a preset and clear, then the circuit will be like this. Here you can see that preset and clear are given. Now these are inverse, so I have to use NOT gate. Now again you see that if I use the preset and clear, then the gate means the first level NAND gate of slave JK so sorry, the master the latch of the master not the fast slave, not the slave, the latch of the master. Here in case of JK, the fast NAND gate is 3 input NAND gate. But if you are not using preset and the clear, then the master of latch of the master is not 3 input NAND gate. But here when you are using preset and clear, then latch of the master is 3 required 3 input NAND gate. So that's why here I have used another particular extra NAND gate, and the output of previous NAND gate is given here, and here the preset, the inverted preset means PR bar, and this is inverted clear means CLR bar. Okay, so when in the net, if you search this truth table of master slave D flip flop, then you will get that preset and the uh, clear are in this form, that PR bar and CLR bar. So this clear bar means this not clear with not gate. So here I take this particular AND gate, okay, and then this output of AND gate is given to the master latch of master. Here you see, whenever this particular kind of you can say 8 kind of circuit uh, wire structure, that means it is a latch. Here you see there is 2 latch, one 8 is present here, another 8 is present here. The first is latch of master, second is the latch of slave. So here in case of preset, and when you are using, when for correct initialization, when you are going to use the uh, preset and the clear, then you have to use a extra NAND gate here, as we are, as simulator doesn't provide us 3 input NAND gate. And then again here you select initially all the inputs are unknown. Again you start the simulation, then do select the do case analysis, and then resolve unknown by gate simulation. Then this unknown will be resolved. Now here when you do the case analysis, you can generate the log. So log will explanation of the log is not important, but you can get a log from this case analysis. So here case analysis means here the particular case where is H trigger or not. Okay, so you don't need to concern about this log part. Here you need to concern that whenever there is X, you have to do this case analysis, means the selection should be here, and then gate by gate simulation, and then you start the clock. You do the gate by gate simulation. Now here you see the particular inputs are not X, inputs are is either 0 or 1. Okay. So after this, if you have any question, you can ask. Okay. Now the register and counter. Now as flip-flop can be used a single bit memory. Now register, what is the basic fastest memory? That is the register which present in the CPU. Now the registers can able to store set of bits, set of uh, bit value. Okay, so here using counter we can build register, and with some modification of in the register we can build, sorry, using flip flop we can build register. What are the flip flop? These are the flip flop: S R J K, D flip flop, and the T flip flop. Okay, so when you are going to build up the uh, register and counter, you do not need to use the gate level implementation. You are going to use the, say this is the example of ring counter, you are going to use the direct chip. Okay, so here in the sequential circuit component drawer you have JK flip flop, T flip flop, D flip flop, and RS flip flop. So you are going to use this flip flop. So say if I take RS flip flop, so this RS flip flop, I show the pin configuration. Here you can see that RS flip flop, it have set reset at uh, 8 and 5, and clock is 7, and QR is 4 and 1. So here, as same as the previous chip configuration, that bottom terminals are output, upper terminals are input. So here you are going to use directly this chip. Okay, now so there is a different type of register. So first, as here you see that design a 4-bit shift register using flip flop and check the output. So you will get the shift registers circuit diagram if you search it in Google, 4-bit shift register. Uh, Here you have to use the uh, flip flop for this. Okay, now here you see that there is several types of register, means 4-bit serial in serial out, means here you give the data input at D. So here you can see that registers are built using mainly D flip flop. Okay, as I told you, the D flip flop is most useful one. So D, you give data input D, then in case of 4-bit serial in serial out, the data output will be come out after a serial uh, shift. Okay, so here you see this is a shift register. How it's a shift register? That the binary number shifted 1 bit at a time from one flip flop to the next. So here when the clock is high, in the first clock it will transfer from this D flip flop to this, then second clock it will transfer from second D flip flop to third. So it will shift from one flip flop to another flip flop for each and every high clock, high value of clock. Okay, now you can check. Anybody have any issue? Okay, anyway, so you can check it by the bit display. Means what? Here you are going to give the output of Q of this first D flip flop to the input of D of the second D flip flop, as well as you are going to take a bit display here, so that you can get the idea that the one is shifting from each and every clock high high clock pulse from one D flip flop to another D flip flop. So this is a shift register. Means what? That the bit value is shift from one bit position to another bit position. So that we are familiar with. So that actual implementation is done by this flip flop. That flip flop bit, one bit flip flop, D flip flop output is 1, then that will be shifted to the next D flip flop when the clock high for high clock value. Okay, high clock pulse. Now for this D flip flop, sorry, in case of serial in, serial out, you are not going to take input output from each and every Q of D flip flop. You are going to take the output from the last Q in case of serial in, serial out. But in case of 4-bit parallel serial in, parallel out, you are going to take output from each and every Q of D flip flop. So here my means for your assignment, as here the assignment is not mentioned clearly in the assignment statement, it is not mentioned clearly. Shift register is there, but the shift register is serial in, serial out, or serial parallel in, parallel out. So here all of you please remember, you implement this one. Means what? 4-bit serial in, parallel out. Means here the input will be given and here the 4 output you are going to get. Okay, so output of each and every Q of D flip flop you are going to show in a particular bit display. Now here these 4-bit parallel in, serial out, 4-bit parallel in, parallel out. Now you are going to do the second one. First you do this register one, means 4-bit serial in, parallel out. Okay, so you do this one first. Then you do the ring counter. So here in the ring counter, this is a 5-bit ring counter. So in case of 5-bit ring counter, you have take 5 D flip flop. Okay, and the ring counter is circuit like this, that this is a synchronous ring counter. So here the clock input is there, and then for the first D flip flop, the preset is set and the clear is not, and for all the other D flip flop, the inverted clear is set. So you are not going to use the particular gate level thing. So that means one input among here in this D flip flop, there is 4 input upper terminal, 4 output lower terminal. Now this, if we click on a particular D flip flop and see the pin configuration, it will going to see, we can see that the input D is in 5. That means this one 5. If I start the pin counting from the bottom left corner, 1 2 3 4, then 5, and the clock is in 8. Okay. Now as which means 5 is D and clock is 8. Now two input terminal is free. Now as it is not clear that among this which one is uh, inverted preset and which one is inverted clear. I take, that's why the output here you can see that output, although I get the bit display 0 and 1, but here you can see most of the wire are maroon. Most of the wire which reflecting here, you can see the output Q is 4 at the, okay, okay. Here I have done a mistake. Uh, Here I have take the output, here I have take the output from D. So this should be this, all this, all this as the output are present in lower terminal. So and Q is present means what, this one bit display will going to show Q bar, another bit display will going to show value of Q. So which one is going to show the Q bar? Here you can see the pin configuration says that Q is uh, Q is present in pin number 4 and Q bar is present in pin number 1. Okay. So here now if I do the connection properly, that means here Q number 1 is present, connect with this first bit display means Q bar, and this second bit display is for Q of the first D flip flop. Then for second D flip flop this bit display, then third bit, the third D flip flop this bit display, then fourth D flip flop this bit display. Now make it simple. Uh, okay, anyway, and then the fourth, sorry, fifth one, the Q bar is this bit display and Q is this bit display. So now if I start the simulation, so here one thing is here this ambiguity is present, but if you design the circuit, that is okay for me. Okay, you design the circuit, uh, means you design the circuit up to this level, that is okay for me. Confusion is that here 4 input is there. It says that the clock is 8 and D is 5. That's okay, but it is not saying, it is not mentioning which one is inverted preset and which one is inverted clear. So I assume you can change it and make sure that try to see that the ring counter is working in a proper manner. In case of ring counter, what happened that ring counter 1 will be means the 1 will be shifted, means in 4-bit shift register the 1 is shifted. Okay, that's okay. But here in case of ring counter, you can see that the last bit, means last D flip flop output, means Q pin 4 output is again go back to the D of pin D flip flop 1. So this make it, means this make ring counter, means what, again it will going to count from uh, means 1 will be again shifted to the particular first D flip flop, and again the register shifting will happen. Okay, modified shift register is nothing but a counter is nothing but a modified shift register. So what is the problem? Problem is that among these two uh, free input terminal, means the pin number 6 and 7, which one is inverted clear and which one is inverted preset, that is not mentioned here. So I have take this particular pin number 7 as inverted PR. Here you can see that in ring counter the first D flip flop have a PR inverted PR value, and second D flip flop onwards all are inverted PR means preset, and second D flip flop onwards all are inverted clear. Now this preset and clear, these are important, as you have seen that the that JK flip flop is a special case of D flip flop. D flip flop is a special case of JK flip flop, and JK have the initialization problems. Obviously, D will have that problem also. So that to overcome that, this inverted preset and inverted clear is required. So this first D flip flop, the inverted preset is used. For all other clear D flip flop, inverted clear will be used. Now here input will be always 0. Sankayan Chaudhuri. কি হলো সাংকায়ন, কি ব্যাপার? সাংকায়ন, Sankayan Chaudhuri, am I audible to you?
Yes, sir.
হ্যাঁ, কি হয়েছে, কি ব্যাপার?
স্যার ইন্টারনেট ছিল না।
ইন্টারনেট ছিল না তাই বলে 1 ঘন্টা বাদে?
হ্যাঁ স্যার, সকালে ওয়াইফাই ছিল না।
তুমি তো আগের দিনও ল্যাব করোনি।
স্যার আগের দিন করেছি।
আগের দিন করেছো? কোথায় অ্যাবসেন্ট? এরকম হলে তো মুশকিল। তুমি আগের দিন ল্যাব করোনি বলেই আমি এখন অ্যালাউ করলাম, নাহলে আমি ডিনাই করে দিতাম।
সরি স্যার, তাহলে বুঝতে পারিনি হয়তো আগের দিন, কিন্তু আজকে স্যার সত্যি নেট ছিল না, এই সবে মাত্র এলো।
এনিওয়ে, দেখো যাতে ব্যাপারগুলো এরকম না হয়।
ওকে
ঠিক
স্যার।
আছে। So anyway, now if I start the simulation, here you can see uh, I simulate it, gate by gate display. I start the clock. Look here, most of the um, q and q bar are unknown. Okay, now I do this resolve gate by gate display. When I do that resolve gate by this display, some x are okay. Anyway, uh, so here, as we have some issue regarding that which pin was means which pin is means which pin and pin 6, which one is preset and which one is clear, inverted preset and which one is inverted clear. Uh, you as this one is ring counter means which you have to build. So as you can see that uh, if I redo the case analysis, I'm doing the resolve the unknown by get bit this, uh, but still I am not getting the correct output. Uh, it is showing unknown for all q and q bar. So it is better that you use pin number 7 as a inverted clear and pin number 6 as a inverted preset. Look, I have used fast D flip flop. I have used pin number 7 as a inverted preset, but it is most not giving output properly. So you use let us try, but you draw the you able to build the circuit, that is okay for me. Okay, output is not proper, that's not a issue. Okay, you draw the circuit properly, you understand the logic, I ask you few question, you able to answer, then that's okay for me. Now here you just change that pin number 6 is preset, means what, here select if I change this one, then instead of pin number 7, I am going to use the preset, this pin number, you are going to use the preset 6, and here for all the inverted clear I have used uh, pin number 6. You instead of that, for all the clear you use pin number 7 for inverted clear. So that's all. If you have any question, you can ask. Otherwise, you solve the problem and let me know when you complete. You share your status in chat box.